So in last lecture, we have seen the basic concepts about the commutation, as well as we have seen the methods to improve the commutation. So we have seen first method, that is a resistance commutation. Okay, so today we will see the EMF commutation, which is also known as interpoles or compoles. Okay, so we'll start. So in that EMF commutation, there are small poles which are fixed on the yoke. Okay, and these are spaced in between the main poles. Okay, you can see here in the figure, this is a north pole, again this is south pole. Okay, again north pole, south pole. Okay, so these are the main poles. Okay, north, south, north, south, and these poles like a south, south, north, you can see these main poles width is a little bit more, whereas these poles having small width. Okay, so that small width poles which are spaced in between that main poles. Okay, this and this here is a main pole, again this is a main pole, this is a main pole. Okay, so I have shown you the main poles, and in between that main poles, this, again these. Okay, so these are the interpoles. Okay, are you getting where are the interpoles are spaced? Okay, so these poles are fixed on a yoke and which are spaced in between the main poles. So these north and south pole, between these two main pole, these small interpoles has been placed. Okay, so they are wounded with a comparatively heavy gauge copper. Okay, that means the gauge of that conductor wire, that is copper wires, are very heavy, which are connected in series with the armature winding. Okay, so why they are connected in series with armature winding? Because to carry the full armature current, they are connected in series with the armature. Okay, also their polarity in the sense of generator is the same, that also whatever our main pole ahead the direction of rotation as shown in this figure, see their polarity is also same like a main poles. Okay, so as their polarity is same like a main pole, then they induced EMF in a coil which help to reverse the current. Okay, so what we have stated, that like main poles, the polarity of interpoles also same, so that of induced EMF in the coil during the commutation is help us to reverse the current. So that induced EMF by the interpoles or the compoles is also known as the reversing EMF or commutating EMF. Okay, that's why this method is known as a EMF commutation. Why? Because the poles or the interpoles which are fixed on the yoke and they are spaced in between main poles which are wounded with comparatively heavy gauge of the copper wire turns, and these are connected in series with the armature conductor to carry the full armature current. Okay, and in case of generator, the polarity of that poles is same ahead of the main poles. So due to that their polarity is the same, hence induced EMF in the coil is help us to the reverse the current, and this induced EMF by these interpoles is nothing but commutating EMF, or we can say reversing EMF. So this commutating or this reversing EMF which will neutralize the self-induced EMF by making commutation sparkless. Okay, as we have seen already, if there is a self-induced EMF, then this will force to generate or produce the sparks. Okay, so the EMF or the
Sir,
commutating, yes, tell me.
माईक जवळ पकडा ना, आवाज लहान यायला लागलाय.
Okay, my voice is a little bit low. Okay, is it right now? Okay now, is it?
Okay,
Yes,
sir.
okay. Yeah, so as we have seen that due to the self-induced EMF, there are production of the sparks which can damage our system. Okay, so by generating or by inducing EMF with the help of that interpoles, which is known as a commutating as well as reversing EMF, so the major function of that commutating EMF is nothing but to neutralize the self-induced EMF. Okay, so as we know that interpoles carrying armature current, so their commutating EMF is also directly proportional to the armature current. Okay, so how we can conclude that generated or the commutating EMF is directly proportional to the armature current. Okay, so due to that proportionality, it will ensures that automatic neutralization of self-induced EMF, which is also due to the armature current. Why we can state like that? Because we know that armature current is directly proportional to the commutating or reversing EMF. So if armature current is changing, then EMF induced, that is commutating or reverse, is also changing, and if it is changing, then it's automatically neutralizing the self-induced EMF. Okay, so we can directly say that there is a relation between self-induced EMF and armature current. Okay, so in shunt generator, connection of the interpoles are shown in that figure 27.14, that this is a shunt generator. Okay, so one more function of the interpole is that to neutralize the cross magnetizing effect. Okay, now we will go for the cross magnetizing effect, which we have seen in during the armature reaction. Who will tell me that cross magnetizing effect? Just anybody tell me. Nobody? Okay, let me explain. Okay, as we have seen that armature reaction has two undesirable effects. That ones is nothing but what we have seen, that demagnetization of DC generator is the first effect of a armature reaction. Okay, the armature reaction is the effect of armature fluxes over the our field fluxes. Okay, then the armature fluxes always opposes to the field fluxes. Okay, and the direction of the armature fluxes always 180-degree phase apart from the field fluxes, or we can say magnetization fluxes. Okay, and same for the DC generator, due to the residual magnetism of the field poles, it takes vital part that generating the EMF across the we can say armature. Okay, so that we have one more thing we have seen, that another effect was a distorting. Okay, so as we know that if the armature reaction increases, then the terminal voltage is decreases. Okay, have you people understand that one during armature reactions? Because nobody replied me, and we have already spent 2 lectures on the armature reactions. So I will repeat again. As we have seen that see, Vt is equal to E minus Ia Ia. So from that equation, we have seen that the terminal voltage across the conductor is nothing but E minus IRA, and if the armature reaction increases, then terminal voltage is going to increase or decrease. It is going to decrease. Okay,
Decrease.
yeah. So uh, we have to, then there is a decrease in terminal voltage, then we have to compensate that armature reaction to maintain that our field fluxes with the induced EMF. To do that, we used that compensating winding. Do you remember that compensating winding we have learned? Why we have used do you understand, or do you remember that compensating winding or not? आठवते का तुम्हाला? कंपेन्सेटिंग वाइंडिंग पाहिले आहे की नाही आपण? का वापरली जाते कंपेन्सेटिंग वाइंडिंग? बोला रे, काहीतरी बोला. नाही बोलायचं तुम्हा लोकांना काहीच? ओके, फाईन. तर आपण कंपन्सेटिंग वाइंडिंग पाहिली होती कशासाठी, तर जे काही आपल्याला इंड्युस्ड ईएमएफ होतं त्या ईएमएफ मध्ये जेव्हा फील्ड फ्लक्सेस आपले आर्मेचर फ्लक्सेस कडून हे होत होते, काय म्हणता येईल त्याला, डिमॅग्नेटाइज किंवा वीक होत होते, त्या टाइमला आपण कंपन्सेटिंग वाइंडिंग ऍड करून आपण काय केलं होतं, आपल्या फ्लक्सेसला कॉन्स्टंट केलं होतं. आणि due to that compensating winding which produces compensative septum fluxes which are 180-degree apart from the armature reaction fluxes. Okay, and the one more thing, that cross magnetizing effect is nothing but distortion of the one field flux due to the effect of another field flux. Distort म्हणजे डिस्टर्ब होणे, एका फील्ड फ्लक्स मुळे दुसरा फील्ड फ्लक्स हा डिस्टॉर्ट और डिस्टर्ब होणं म्हणजेच क्रॉस मॅग्नेटायझिंग इफेक्ट. दॅट मच सिम्पल. हा, now you are clear or not? Okay, Anil Kamble, hello, can you hear me, Kamble? Hello.
Yes, sir.
Yes, you are Swapnali Kamble. Anil Kamble, roll number 35. Is my screen is visible to you or not? I think you have you have not proper internet connection. Please check with your connection. Anybody other who is facing issue with visibility of screen? Anybody? Everybody is able to see screen, na?
Yes, sir.
Yeah, Kamble, please check your internet connection. Anil. Yeah, fine.
Internet connection disconnected.
Yeah. Okay, fine. Now we'll go for the next one. That, as we know that another one function of the interpoles is to neutralize the cross magnetizing effect of armature reaction. Now आता तुम्हाला समजलं असेल की इंटरपोलचं दुसरं काम काय आहे, तर क्रॉस मॅग्नेटायझिंग इफेक्ट जो आर्मेचर रिएक्शन मुळे होतो तो पण न्यूट्रलाइज करायचा. पहिलं काम काय होतं, तर जे सेल्फ इंड्युस्ड ईएमएफ होतं त्याच्यामुळे जे स्पार्क्स होत होते त्याच्यासाठी आपण काय केलं की एक रिव्हर्सिंग और कम्युटेटिंग ईएमएफ जनरेट व्हावं त्याच्यासाठी आपण एक इंटरपोल्स ऍड केले. आणि त्या इंटरपोल्स मुळे काय झालं की ते इंटरपोल्सची जे काही वाइंडिंग होती ती कॉपरची हेवी गेजची होती. हेवी गेजची वाइंडिंग असल्यामुळं आणि ती सिरीज मध्ये कनेक्ट होती कोणाच्या, आर्मेचरच्या. तर आर्मेचरच्या सिरीज मध्ये कनेक्ट असल्यामुळे पूर्ण आर्मेचर करंट हा त्या वाइंडिंग मधून फ्लो होत गेला. आणि ड्यू टू दॅट तिथं काय झालं, ईएमएफ जनरेट झालं. त्याची पोलॅरिटी आणि आपल्या मेन फील्ड पोलची जी पोलॅरिटी होती ती सेम असल्यामुळे जे जनरेट होणारे ईएमएफ आहे ते काय केलं की सेल्फ इंड्युस्ड ईएमएफ ला न्यूट्रलाइज करत गेलं. ओके, त्याच्यामुळे आपली जी काही कम्युटेशन प्रोसेस होती ती स्पार्कलेस होत गेली. हे आतापर्यंत आपण पाहिलं. त्याच्यानंतर आपण पाहतोय की इंटरपोल्सची दुसरे काय बेनिफिट आहे किंवा दुसरं काय फंक्शन आहे, तर देर इज अनदर वन फंक्शन दॅट they will neutralize the cross magnetizing effect of the armature reactions. Okay, due to that brushes are not shifted from the original position. Okay, so the neutralization of the cross magnetizing is automatic and for all loads because both are produced by the same armature current. Okay, so difference between interpoles and compensating winding, I think you people are cleared with that. Yes or no? अरे इंटरपोल आणि कंपेन्सेटिंग वाइंडिंग याच्यातला तुम्हाला फरक कळाला का?
No, sir.
ओके, एनीबडी एल्स? अजून कोणाला कळालं नाही? अरे तुम्ही बोलत नाहीत तर मला कळणार कसं, तुम्हाला समजतंय का नाही? हा
सर मला नाही समजलं.
कोण आहे? लेट मी चेक. चंदना.
हा,
okay, fine, no problem. We will consider that nobody understood the difference between interpole and compensating winding. okay, आता मी परत एकदा एक्सप्लेन करतो इंग्लिश मधून एज वेल एज मराठी मधून. आता केअरफुली ऐकायचं आणि त्याच्यानंतर मी क्वेश्चन आन्सर करणार हे कन्फर्म आहे. ओके, सो बी केअरफुली, लिसन केअरफुली. सो पहिल्यांदा पहा, compensating winding and interpoles both are used for same purpose. okay, but difference between these two is nothing but interpole producing EMF for the neutralizing that self-induced EMF. Okay, one thing you have cleared, that interpole is producing or generating EMF for the neutralization of self-induced EMF. Okay, but
Yes,
com-
sir.
but compensating winding produce an MMF, that is nothing but magnetomotive force, means magnetic field, which opposes the MMF produced by the conductor. आता तुमच्या लक्षात येत आहे का, कंपेन्सेटिंग वाइंडिंगचं काम काय होतं, तर ती एक MMF, ती मॅग्नेटिक फील्ड जनरेट करत होती, जी की कंडक्टरने तयार केलेल्या मॅग्नेटिक फील्डला न्यूट्रलाइज करत होते. आणि इंटरपोल काय करतायत, तर ते EMF जनरेट करतायत जे की सेल्फ इंड्युस्ड EMF ला न्यूट्रलाइज करतायत. डिफरन्स कळाला दोन्हीतला?
येस सर.
हा, अगेन आपण थोडस डीप मध्ये पाहूया. कंपन्सेटिंग वाइंडिंग काय असते, तर ऑल आर्मेचर कंडक्टर्स placed under the main poles region produce EMF which is right angle, that is 90 degree to the main field, and this EMF causes distortion in main field flux. So this is also known as cross magnetizing effect, which we have seen. Again, that compensating winding is used to minimize the cross magnetizing effect. Okay, so as we have seen that this compensating winding produces an MMF which opposes the MMF produced by the armature conductors. Okay, so this is the objective, that is why we are connecting the compensating winding in series with armature conductor. Why? Because to oppose the MMF produced by the armature conductor. Okay, so जर compensating winding useच नाही केली, then what will happen, then in the absence of compensating winding there will be cross magnetizing effect which causes that sparking at commutator and short circuit the armature winding. कळालं इथपर्यंत? कळालं का?
हो.
हो
हा.
सर.
ओके, व्हेरी गुड. आता आपण असंच थोडंसं डिटेल मध्ये काय पाहूया, इंटरपोल्स पाहूया. तर इंटरपोल्स म्हणजे काय, इट इज अ व्हेरी इन स्मॉल साइज. ओके, अँड दे आर प्लेस्ड इन बिटवीन मेन पोल्स. ओके, ते कुठे प्लेस केलेले असतात, मेन पोल्सच्या मध्ये प्लेस केलेले असतात, दोन मेन पोलच्या समान डिस्टन्स मध्ये प्लेस केलेले असतात. आता कंपन्सेटिंग वाइंडिंग सारखंच इंटरपोल्स पण काय असतात की कनेक्टेड इन सिरीज विथ आर्मेचर कंडक्टर. ओके, बट आपले जे कंपेन्सेटिंग वाइंडिंग आहे ती काय करते, MMF प्रोड्यूस करते. कशासाठी, तर आर्मेचर कंडक्टरने जे MMF जनरेट केलेलं आहे त्याला अपोज करण्यासाठी काय करते, MMF जनरेट करते. हे कोण करते, कंपेन्सेटिंग वाइंडिंग. पण इंटरपोल्स काय करतात, तर इंटरपोल्स हे EMF जनरेट करतात. येते लक्षात, EMF जनरेट करतात कशासाठी, तर जे सेल्फ इंड्युस्ड EMF आहे त्याला अपोज करण्यासाठी. क्लिअर आहे आता?
येस सर.
Okay, so shall I ask questions? Who will tell me that interpoles, what is the function of interpoles? Who will tell me? Bharti Lingde, roll number 5, tell me. Bharti, tell me. Unmute yourself. Yeah.
It is produces at EMF.
Okay, interpoles produces EMF. Okay, very good. Why this is producing EMF? For which purpose? Repeat after me. That interpoles produces EMF which neutralize the self-induced EMF. Okay, repeat after
Yes.
me now.
Which neutralize the self-induced EMF.
Yeah, very good. Now I will ask to Rushikesh Gaikwad, roll number 16. Please unmute. Rushikesh.
हा सर.
Yeah, tell me where these interpoles are placed. Interpoles कुठे प्लेस केले जातात? Rushikesh Gaikwad, roll number 16. I am asking to you. Please unmute yourself and answer. It's very simple. First sentence of our lecture was that one. Who will help to Rushikesh? Suraj Dudhal, tell me where these interpoles are placed. See guys, if you guys are not responding, then it will not enjoy full lecture.
Hello, yes, sir. Hello.
Suraj, your internet connectivity is poor. Okay, Harshal More, tell me where that interpoles are placed.
Hello, sir. Hello.
Hello, Harshal. Harshal More, unmute yourself.
Yes, sir.
Yeah, tell me where that interpoles are placed. If you guys don't know, then just you can tell me, don't know, sir.
Not no, sir.
Okay, Shreyash.
Hello, sir. Hello.
Yes,
Shreyash,
sir.
yeah, tell me where that interpoles are placed.
In between the main poles.
Yeah, very good. And
Same distance in between the main poles.
okay, and are they connected in series with armature conductor or in parallel?
Series with armature winding.
Why these are connected in series?
Flowing current in maximum.
Yeah, very good. That to carry the full armature current. Very good. Okay, then Salgar Priyanka, unmute yourself. Priyanka, are you there? Priyanka Salgar, can you hear me? Okay, Swapnali, are you there? Swapnali Kamble. Yes, Priyanka, tell me. Priyanka, can you hear me? Hello. Okay, Rushikesh Vatare.
Sir.
Can you tell me what is difference between compensating winding and interpoles? When you joined the lecture?
आता सर 5 मिनिट.
Okay, so you missed that part, right? Okay, no problem. We will repeat again. Anmol Raut, can you tell me the difference between compensating winding and interpoles, please?
Don't know.
Okay, don't know. Mohini. Mohini Gaikwad. Okay. Then who will remaining? We'll ask to Ramkrishna. Ramkrishna, unmute yourself.
Hello.
Tell me, Ramkrishna, what is difference between interpoles and compensating winding? Tell me.
Interpole, it is a place in made of main poles.
Okay, very good.
Compensating. Hello.
Yes, tell me, I'm listening.
And compensating winding is wind to the cores.
Okay. Okay, fine, very good. Okay, let me explain once again. Read, listen carefully. Okay, the difference between compensating winding and interpoles is the simplest. That is, interpoles are used to, or the function of interpoles is nothing but to neutralize the self-induced EMF which is caused due to the armature current, and interpoles produces commutating or reversing EMF. Okay, so interpoles are, again I will repeat, interpoles are placed in between main poles. The polarity of main poles and the interpoles are same, and that of the EMF will get generated and it will oppose to the self-induced EMF. Again, another function of the interpole is nothing but to neutralize the cross-magnetizing effect of the armature reaction. Okay, and the compensating winding is also connected in series with the armature, and this function of compensating winding is to produce the MMF which will oppose to the MMF produced by the armature conductor. Okay, so this is the difference. I hope you guys understood. So as these both are connected in series and due to their MMF and EMF, they are just neutralize the armature reactions too. So interpoles additionally supply MMF for counteracting the self-induced EMF in coil under commutation. Okay, so this is all about the EMF commutation. You guys understood. I think last lecture we have conducted about the commutation as well as resistance commutation, and today we have seen the another method of to improve the commutation is nothing but EMF or EMF commutation or interpoles, or we can say compoles. Okay, so I hope if there is a question on for 4 marks in an exam about the commutation, write commutation and explain the methods to improve commutation, then easily you will get out of marks. So you have to draw 2 diagrams. Okay, you have to explain commutation, what is commutation, what is the process, all that things you need to explain. After that you have to give the methods for the improvement of commutation, the resistance commutation, and another one is our what we can say EMF commutation. So both things you have to explain properly. Okay, is there any doubt about the commutation?
No, sir.
No. Okay,
No, sir.
yeah, fine. Okay, so I request you all to please rejoin immediately. So we'll start another 1 point, power stages. Okay, and then we will stop. Okay, so rejoin immediately.